بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله تعالى وبركاته. My name is Mahad Ahmed kadiye, and here I will present my master project 2. The title of my project is Correlation Analyzed on Groundwater Effect for Clay Layer in Johor, Malaysia. And here it is my name, Mahad Ahmed kadiye, and my metric is HF 19002. And my supervisor is Dr. Sabaria bint Musa. And my panelist is Dr. Muhammad Arif Ahmed Nazri and Dr. Azra Munira Mahad Daoud. Here this is my outlines of the presentation, introduction, treasury review, methodology, result, and conclusion. Here this the introduction. As you know, my thesis was analyzed XRD and XRF correlations. As you know, XRD and XRF method was used in this study. XRF performance was used a non-destructive technique to assess the element composition of the clay soil, while XRF giving information on the crystallized species present in the clay sample and could differentiate between compounds. The main goal of XRF diffraction and XRA scattering was to determine the crystallized structure of sample or to identify the measure the crystal phase in the sample of soil. Here the problem statement. The problem statement the Johor is going to face an extreme water shortage in many of its states, and on the verge of the serious water crisis in the future if all appropriate steps are not taken in time. As a result of discrepancies between groundwater charge and usage, a significant volume of precipitating water is wasted by surface rains. The issue of groundwater is getting worse. Low filtration rate during the heavy rainfall is dependent on the specific problem. The conjunction of the residual system with the pumping method has capacity to absorb and generate further surface runoff or high rainfall intensity during the wet season. In soil samples, parameters include heavy metals, pH, manganese, sulfide, chloride, chemical, physical, etc. Here the objective is to identify groundwater characteristics in terms of geochemical analysis and soil type equivalent, to correlate the groundwater quality affected to groundwater layer by geochemical analysis. This is the scope of the study. This study lives geochemical natural water analysis system are built to eliminate for groundwater correlation or contribute to the virtual of the microorganism primarily associated with the solid hang on water from microbiological, tonic, and physical contents. Here the scope of study, evaluating the efficiency of groundwater management principles, dimension components by experimental testing for groundwater treatment, measure geochemical by X-ray fluorescence analysis, measure the X-ray diffraction analysis for soil sampling, evaluate the data to analyze for each segment correlation. Parameters include heavy metals, physical, and etc. And here this study was done to identify groundwater quality characteristics in terms of geochemical analysis in UTHM area. This is the literature review. I checked some parts of my literature review like groundwater quality, geochemical analysis like X-ray diffraction, X-ray fluorescence. And here the methodology. In this chapter, geochemical analysis and correlation of clay layer of soil sample were explained in order to analyze the effects of groundwater layer in research center, following the different methodology to achieve the goals set out in the study, and to explain the correlation between groundwater quality and heavy metals and dioxide, manganese, and sulfate by analyzing X-ray fluorescence and X-ray diffraction with comparison the groundwater quality. The parameters of sulfate chloride sulfide, chloride, geochemical X-ray fluorescence, and X-ray diffraction analysis. Measurement and analyze is based to proceed the coloration of soil layer. However, a new system established in the Research Center for Subsoil Utah for treatment of groundwater for each segment method, and it described each step to be taken during this study. This is my flow chart, and this is separated in two parts. It's soil sample and geochemical sample. Soil sample is a physical part, and geochemical is a chemical part. You know, and this parameter is pH, dioxide, manganese, sulfate, and chloride. And this part for geochemical, there is a common parameters. Then I will make correlation between of them. If there is a correlation, we'll come back to the data collection. If there is no correlation, it will come back to the there is okay, then we make conclusion. And this is the data collection. The selected area is located at Research Center for Utah, and the data was drilled since 2018 for groundwater purpose. And here the soil characteristics of aquifer and soil type characteristics of deep well were sampled, and soil sample were taken along the transects at high spatial resolution. And this is the data or the raw data of XRE study content of contamination in groundwater parameters sourced by National Water Quality Standard for Malaysia, and the other part is raw groundwater data. This I get my professor, Dr. Sabaria bint Musa. That's what I used to analyze some part of the physical parts like XRF. And here the results and discussions. XRD and XRF methods were used in this study. XRF fluorescence was used as non-destructive technique to assess the elemental composition of the clay soil, while XRD give information on the crystallized phase present in the clay sample and could differentiate between compounds. The main goal of XRD diffraction XRD scattering was to determine the crystallized structure of sample or to identify the measure of crystallized phase in some sample of soil. In the XRD equipment was implemented with instrument and associated that all allowed for fertilization of the interior of a structure and the clay particles in order to identify their non-particle size distribution. The goal of this study was to identify the groundwater characteristics of the aquifer in terms of geochemical analysis and soil type aquifer, and correlation groundwater quality of the groundwater layer using geochemical analysis. The finding of this study of the clay water sample collected at various depths ranging from the groundwater level to the 8.8 were given in section 4.2 4.3 together with an analysis and discussion for of the result. And here the XRD part. XRD result for 1.5 meter depth. So this result was done in the previous. Only I'm making for the what we call analyze. So the result from the laboratory was analyzed, and the peak was compared to known diffraction patterns to help in quantification. However, its same peak are significantly larger than us. It is likely that different clays are presented. The result of XRD of clay minerals at 1.5 meter depth. The XRD test result was presented as bar diagram with the appropriate by weight of each minerals. The graph of quant values to indicate that a clay sample includes 75.28% of quartz, percentage by colonite and the jorcite, which was discovered at 10.21% and 8.75% in late perspective. The peak intensity is greater at the 26.5 position, and this is the pie chart that shows the percentage. XRD analyze. XRF performance was used non-destructive and technique to determine the elemental composition of the clay soil. The composition of clay sample was determined using the XRF performance. XRF gives quantitative elemental analysis for which the clay content was estimated. The findings of XRF analysis of clay sample taken at depth 1.5 are shown in table 4.1, and this is the table 4.1. Parameters and XRF. So each one and each one of his percentage in the table. The correlation analysis between XRF and XRD. The purpose of XRD was to determine the crystal structure of a material or to detect and quantity crystallized in clay soil sample. The XRD equipment was supplemented with instruments and sensors that allowed for visualization of internal structure of clay particles in order to identify their non-particle size distribution. XRF performance was using non-destructive and techniques to determine the elemental composition of the clay soil. XRD provided information about the crystallized phase present in the clay sample and can distinguish between components. The correlation between XRF and XRD research will be performed in this section. The result of both XRD and XRF are shown in table 4.2 at the same depths of 1.5 below ground level, and the table also includes the average of XRD and XRF result. Here the correlation between XRD and XRF and average, and this is the pie chart that shows the average by concentration. This is the correlation of XRD and XRF for various parallel depths. This is the correlation of XRD at depths of 1.5 meter. B is a 0.05 correlation is a significant. A correlation study between XRD and XRF was presented in table 4.2 above. The table 4.3 was used to create the correlation. Data was analyzed in the Excel spreadsheet to determine the correlation between the XRF and XRD research. Therefore, the correlation between XRD and XRF correlated is equal to the 0.91, which shows high significant correlation as B0.91 to the 0.05. And the other part of my result is discussion analysis, correlation and groundwater quality characteristics in terms of geochemical analysis. The objective in sampling to identify the groundwater characteristics in terms of geochemical analysis and soil type aquifer is to obtain small composite sample to be tested. The second objective is to correlate the groundwater quality affected to groundwater layer by geochemical analysis. According to the soil sample instruction to the sample field from XRD, a map that identifies each area is the field where sub-samples were taken should be defined. This composite is compared of 48 in concentration of soil from sampling area. 14 cores is taken at the depths of 1.5, 3, 9, 10.5, 12, 13.5, 15, 16.5, 18, 21, 22.5, 25.5, 28.5, 48, and the content includes chloride, sulfide, chloride, nitride, manganese. All the data described through the table which provided the average mineral content was analyzed to compare the recorded standard. The groundwater characteristics in terms of soil aquifer. Soil sample was taken from the surface to the depth of 48 in probing situation. The scalies are placed in a clean plastic bale, then mixed thoroughly. The mixed was separated out of clean paper to dry in open air, then crushed and ground to powder from foam before beginning analyzed by X-ray fluorescence machine. An X-ray fluorescence analysis is to determine the chemical composition of soil. The below table is a combination of X-ray and X-ray for chemical correlation in the soil. This is the correlation analysis. They typically found in soil oxide minerals includes oxide, hydroxide, hydroxide, and hydrated oxide of SiFeMn and expressed for Ci oxide, quartz, and Ft oxide, which are mostly inherited from primary minerals. The majority of oxides are formed in the soil. This is the chemical composition in soil, XRD and XRF, and their correlation. Groundwater quality analysis. Analysis of groundwater sample as tabulated in the table. The result of the analyzed groundwater is compared with a groundwater standard and Minister of Health standard. According to the groundwater standard, the value of groundwater in the range of standard, but certain essential minerals are present in low concentration. Also, it is noted that the groundwater has a high possibility to be used drinking water due to the presence of some minerals such as calcium, magnesium, zinc, iron, sodium, potassium chloride, and nitrate, sulfate, and fluoride as essential minerals of human health. This is the table for the study at UTHM Musa, Dr. Sabaria Musa at AL 2015. This is the data we used to make the correlation. The previous study area UTHM KKM is a standard for Malaysia, groundwater quality standard, low water criteria, and MHO drinking water standard. Minister of Health. Correlation analysis. Correlation is the statistical tool that helps to measure and analyze the degree of relationship between chemical concentration in soil and raw water parameter quantity. This is the correlation. I will get 0.43. So when we analyze it, we get 4 parameters: silicon oxide, aluminum oxide, potassium oxide, iron oxide, and magnesium oxide. And we make the value of correlation coefficient is 0.4, and it was considering a strong correlation failure. The presence of high concentration of oxide metal is the soil resulted to low concentration. The icon is in the groundwater. It could be concluded that the soil at the study are area containing major and minor element of metals. The concentration of the major and minor element oxide have been noticed with change in depth. Conclusion and recommendation. This is chapter 5. Groundwater will normally look clear and clean because the ground neutrally filters about particulate matter. But neutral and human indicate chemicals can be found in the groundwater. As groundwater flows through the ground, metal are dissolved and may later be found in high concentration in the water. At the conclusion of the study, it is essential to reflect on the initial object of the research. The first objective of this study was to identify the groundwater characteristics of the aquifer in terms of geochemical analysis and soil type, and the second objective to correlate the groundwater quality of the groundwater layer using geochemical analysis. The objective of this study was achieved. X-ray fluorescence. was used as a non-destructive technique to assess the elemental composition of the clay soil, while X-ray diffraction and X-ray scattering was analyzed as samples crystal structure or to identify the quantitative crystal phase in the sample clay soil. Equipment was extended with a tools of series to visualize internal structure of the clay particles. After XRD and XRF analyzed, the most dominant element was used to correlate the ground characteristics correctly in previous study. The finding of this study was summarized below. The SIO is a simplest main component in both XRD and XRF analysis. Aluminum oxide in the both analyzed KO2 was the this oxide found. There was other oxide that found in the same depth and displaced to other compounds like Fe oxide and manganese oxide. The correlation value in the XRF and XRF were in between 0.88 to 0.98, considering high correlation. SIO is the simple main component in both XRF and XRF analysis, and aluminum oxide in the both analysis. Depths. Oxide that found in the same depth and displaced to the compound like Fe or manganese. Conclusion: the XRF and XRD analysis was taken the dominant minerals such as sulfide oxide, aluminum, and KO to correlate with groundwater data taken from previous research done by Dr. Sabaria Musa, and the value of correlation between groundwater and soil was found equal to 0 before, and it was considered strong correlation. The percent high concentration of oxide entered the soil resisted low concentration like on the groundwater. It could be concluded that soil of the area containing mere and one element of metal. The concentration of the mere and element soil have been noted with change in the depth. Application for field. The following are the same recommendations found during this external analysis. Very useful technique to use several sectors, include element composition of material and analyze the structure of quantized material. Therefore, this useful will be good to extend research using XRF and XRD. Result of this study can be compared with the other research results. Engineers who want to do study related to XRD must be familiar with XRD analysis software as a region. This future work is coverage given in it to future research area they can extend their study. XRD, XRF, surface water characteristics may be tested to get understanding if the soil characteristics have effect to surface water in mutagen campus. Work can be extended to other mutagen boreholes. Groundwater in particular can be tested to get understanding if the soil have affected the groundwater at the area. Thank you all for your kind attention.